Let's determine whether the sequence given by a sub n equals n factorial divided by 2 to the n power converges or diverges. To determine convergence, let's try to analyze the sequence by looking at some terms. Let's calculate the first few terms of the sequence. Looking at these terms, we can see that the sequence appears to be increasing. Let's visualize this with a graph. To determine if this sequence converges or diverges, let's try to analyze the ratio of consecutive terms. We can use the ratio test to help us understand the behavior. Let's simplify this ratio. First, we can multiply the fractions. Then, we can simplify the factorial. Finally, we can simplify the powers of 2. Now, we can evaluate this limit. As n approaches infinity, the ratio n plus 1 over 2 also approaches infinity. Since the limit of the ratio is greater than 1, this tells us that the sequence diverges to infinity. This makes sense intuitively because the factorial in the numerator grows much faster than the power of 2 in the denominator. For large values of n, the factorial dominates, causing the sequence to grow without bound. Therefore, we can conclude that the sequence of sub n equals n factorial divided by 2 to the n power diverges to infinity.